Today I'll look at some applications of sinusoidal functions. You need to watch the graph of sine and translations of the sine function before you do this one. So make sure that you watch that before we go into here. Okay. So let's get started with remembering what a simple harmonic motion was. Okay. A motion is simple harmonic if its displacement is, if, let's word it that way, the displacement of a point about its rest position can be determined by a formula that is like this or like that. All right. Well, let's look at a problem. If somebody says, we have a pendulum and you have the pendulum right here and you just pull it on one side at time 0, and let's say my scale is like that, and this is 6 centimeters away from where it got started. You just hold it up and then let go, okay? And this thing is going to go back and forth and back and forth. Now, if you're doing it, if you're doing this in vacuum, there's no area resistance. This is going to go back and forth and back and forth. All right? But because of air resistance, it's going to kind of lose its initial potential energy, and it's going to stop after a while. Okay, so let's say my d of t, that simple harmonic motion of that pendulum, is given as the initial location of it times cosine, the period of it, and t is the time. So this is going to be in seconds, and this is going to be in centimeters. Okay? And you can actually go and calculate the position of that ball, the pendulum ball, at different times using that thing. And this is a great application of a trigonometric function. Let's say in d of 0, at time 0, what do you have? You have 6 times cosine of 0, and cosine 0 is 1. So it is 6 centimeters. At time 0, it is 6 centimeters away from its rest position. Let's say at 1/4 of a second, what do you have? 6 times cosine 2 pi times 1/4. So it is 6 cosine of pi over 2. And I know cosine of pi over 2 is 0, 0. So in other words, it's going to start here. After 1/4 second, it's going to be right where the rest position was. What will happen at, so this one is t equals 0, and this one is t equals 1/4 seconds. what will happen at d of 1/2 seconds? And let's go look at that. At d of 1/2 seconds is going to be 6 times cosine 2 pi times 1/2, and which is 6 times cosine of pi. Do you remember what cosine of pi was? That is on the other side of the unit circle. So that was -1. So it's -6. In other words, what happened at t equals 1/2 seconds, it went on the other side. Okay, so it's at 6 centimeters again. But this time it's to the left of where you got started. So you can actually do a lot of, plugging in kind of thing and understand how the simple harmonic motion works. Let's look at a spring that is also follows a simple harmonic motion. So let's go look at that. Let's say you have some like this, and then d of t is -5.2 cosine of pi t. And that's given to you. And you can actually say, okay, what happens? And then you kind of go, pull it down, bing, and then it goes back and forth. So at time 0, d of 0 is simply -5.2 cosine of 0. And cosine of 0 is 1. At time 0 is, you're at -5.2. All right? So you have that, and that means you're going to pull it down, and you start at that location. And at time 1/2, what is d of 1/2? That's going to be -5.2 cosine of pi over 2. And I know cosine of pi over 2 is simply 0. So it was at -5.2. So it was at -5.2. Okay, we started at that, and then we let go, and it bounced back to 0. Does that make sense? So you can actually plug in numbers and kind of get that. All right. The other concept that you have here is the concept of period when you talk about simple harmonic motion. And since we are talking about sine and cosine, the period is 2 pi. But if you have a situation where, remember the graphs of sine and cosine, and we are dealing with sine of bt or cosine of bt in the formula, so your new period is simply going to be 2 pi over b, whatever that is. And if it is 2, your period is going to be pi. In other words, whatever that your particle is doing is going to repeat at every pi instead of every 2 pi. So kind of pay attention to that. And the other thing is the concept of frequency. And your frequency is simply 1 over your period. So if somebody is asking you, what is the frequency, and you know that this is equal to that, and 1 over t, so it's going to be b over 2 pi if that b is in front of your t in your formula. So you can do a couple of application problems, but basically that's what we're talking about.